Think forward. Think Research Channel.
Well, you know, seeing is believing, right? And the Center for Visualization is really aimed at giving us a new way of seeing, a new way of interpreting what we see, of thinking about what we see, and that's critically important. New ways of seeing have driven science in the past, and I think new ways of seeing will help us drive new science and new ways of thinking about our world.
The Center for Manufacturing is a non-academic unit within the College of Engineering.
However, the number of faculty that are involved in the center come from different academic units within the College of Engineering.
And they work collectively
to do research in very interesting areas that are related to manufacturing.
But they also are focused on being applied and trying to help manufacturers out.
In addition, we have a Master of Science in Manufacturing Systems program,
where the students get to do everything that they learn in the class.
Because of the good work that they do, our graduate students get picked up for jobs long before they even graduate.
It is very important that we have a strong research element in the center.
The center provides a very nice facility and environment for us to do research.
In summary, the center has three missions: education, research, and technical service.
The Center for Manufacturing is now 20 years old. It's a key element in the College of Engineering, and in many ways I think that it's transformed the College of Engineering through its linkage with industry. It's enabled our departments to work more closely with industry than had been the case in the past. It's given us capabilities to serve industry that we did not have before that, and it's certainly enabled our students to explore new educational experiences that are important to industry that were not present in the college before.
So the Center for Manufacturing actually has a three-pronged mission. First is academics. We actually run a Master's in Manufacturing Systems program. We also run lean boot camps for students. So students learn then manufacturing processes, and they learn about lean production. The second prong is our extension. Similar to our colleagues in ag, we go out amongst the community, particularly Kentucky manufacturers, but also domestic manufacturers and even international manufacturers, and help them with their manufacturing problems. And the third prong is the research prong. So many times in these trips that we take out to local manufacturers, there are simple problems to be solved that can be solved by our extension engineers or a group of students. Then there are more complex problems, and then there are fundamental problems, research problems that have not been solved. And those we have our faculty then work on, usually supported by federal funding, National Science Foundation, for example, and generate PhD students and publications then, in addition to solving the initial problem that was presented to us.
Overall, my experience has been really good with the Center for Manufacturing. I have also found, now this is something that I found rare. I have found the people over here to be really helpful, even though they may not directly know you, but they are really polite and really helpful when they deal with you. So overall, it's been a good experience.
Well, the Center for Manufacturing is instrumental in bringing more manufacturing type of knowledge base to the College of Engineering. We have developed curriculum and helped influence the curriculum so that the students are getting a lot more exposure to manufacturing type topics, so that if they're interested, they're prepared to work in a manufacturing environment when they graduate. We also initiated the Manufacturing Systems Engineering Master's Degree Program so that engineers with background in electrical engineering or mechanical engineering or any of the disciplines can then go to a master's level and get a degree that will help them be successful in manufacturing environments from a systemic level. In other words, they don't have to focus just on electrical engineering graduate type work. They can apply the electrical engineering work in a systemic type of environment from a manufacturing perspective, and that's what they're learning in our master's program, and our center sponsored that and the curriculum development for that.
In our Master's in Manufacturing Systems Engineering program, we have 4 core courses, and those are important to kind of indicate the breadth that we want those students to have. The first of those required courses is a processes course, because all of our students should have an understanding of the processes, whether it be machining, whether it be forming, whether it be brazing, all of the traditional and even non-traditional manufacturing processes. We have a systems course, which is the second in the required course, which really helps them understand how all the pieces of the puzzle in the operation fit together. The third piece is an organizational behavior class, and the reason why that's in there is because the success of operating a manufacturing facility relies not just on the technical knowledge of the processes and the systems, but also on the human dynamics aspects, the organizational behavior aspects. And so we think that it's really critical that students know and understand that. The fourth one is a project and seminar course, and in that project and seminar course, the students are actually presenting material much of the time to each other, so that they're ending up with a fairly broad exposure, but even more importantly is that they are also working on industry projects.
The Center for Manufacturing has really enabled us to expand our faculty, especially in mechanical engineering and electrical engineering, with individuals who have a manufacturing focus.
Faculty in the Center for Manufacturing are multidisciplinary. So we have faculty from mechanical engineering, from electrical engineering, from chemical and material science engineering, and they work collectively to help manufacturers on applied type research as well as furthering the knowledge in these manufacturing research areas to be able to share that knowledge then later with manufacturers. They will pull in resources of other faculty within the College of Engineering when necessary, but we just have a wonderful team that will work together and are very interested in working with industry and working on not just basic and fundamental type research, but also applying that and sharing that information with students in their classes as well.
Educational component of our activities involves master's studies and doctoral studies. Center's position within the college is unique in the sense that it involves a number of departments. This center in particular has good connections, and faculty are coming from different departments with mechanical engineering, electrical engineering, materials, and so on.
The nice thing about the center is it's a blend of different areas in engineering in one single place. And this kind of integration, you don't see it in any other department. So you go to mechanical engineering department, you see only mechanical engineering, the same thing in electrical, and I would say the same thing in industrial. Now here we have a blend of mechanical, manufacturing, material science, and some electrical engineering. We have professors from each one of these divisions of engineering, and we have students working on quite unique projects that blends these different engineering areas. For example, like I got my PhD in mechanical engineering, but still I did some mechanical engineering research, some material science research, and of course some manufacturing research. So I could think of my PhD work as a blend of these three areas. And I would say the Center of Manufacturing played a very important role in giving me this combination, because we had all the facilities from all these different areas in one single place.
Students can also get involved through the center through the Lean program. They can take our Lean boot camps, there are 3 of those, and get graduate credit for it. They also become very high in demand when they get through those programs. They're wanted by Kentucky manufacturers and domestic manufacturers and even international manufacturers.
The students are highly involved. It's an interactive, hands-on activity that the students together work as first a non-lean environment, which would be a very traditional non-pull system, as it's called, but just a very traditional, build the product and build it to some storage area, build it to some inventory area, and then it's pulled from that inventory area and go to the next process. Lean manufacturing is classified as a pull system or a lean system, which takes that chain of activities and reduces the lead time from the time the product started to when the product is actually delivered to the customer, hopefully.
So the bootcamp program that we have through the Center for Manufacturing is a very intense program on lean manufacturing that we offer to our graduate and undergraduate students. We have 3 boot camps that have been structured such that boot camps 1 and 2 are 4-week programs that are offered in parallel in the summer, and we usually start this in May. So the students would go to get through boot camp 1 or 2 in a given summer session, which is a very intensive 4-week program where they pretty much spend the entire time in the boot camps doing the various simulations, working in groups with various assignments, and they really live lean manufacturing during that time. Those are the 2 first boot camps that we offer in parallel, and then in the second summer session we offer boot camp 3, and students would go through boot camp 1, then boot camp 2, and finally through boot camp 3 to get through the entire series of boot camps that we have. Once they go through the 3 boot camps, they would be completing 18 credit hours in the lean manufacturing program, which would give them a very good background on lean manufacturing, and they are pretty much ready to go and get started in the industry.
Well, a key element in the vision that the state had when they provided the resources to this University of Kentucky for the creation of the Center of Manufacturing is that we would work with industry. We do that not only through the Lean Manufacturing program, but we also do it through outreach where our engineering staff, for instance, will visit a company, give them recommendations on how to revise their manufacturing processes to be a more efficient and more competitive player in the global economy. We also work in terms of rapid prototyping, where companies will bring us early stage ideas on product development. We'll work closely with them in terms of how to design that element for manufacturability, how to design that product so that it can be designed with the least cost and the least waste by the manufacturer.
As far as what we do for industry, over 90% of our work that we do in this department is for industry. We are a full-service prototyping shop, so a lot of manufacturers come to us to produce prototypes for them when they create a new product or they redesign an existing product. They will contact us to manufacture the prototypes for them so they can do their testing and evaluation.
Well, we've had an excellent relationship with the University of Kentucky and the Technical Services and Engineering Division there. Several years back, we decided to manufacture our own branded intercom system. But we decided that we wanted to enter that market with our own private brand, and we set about a design concept. And the first thing that we tried to do was to come up with a concept that really looked different and modern rather than square little metal boxes that you typically see.
When you're developing a product, it's important that you prototype that because it gives you an idea of any problems that you're going to have in production, or even the assembly of the product, or even the function of the product. It's a lot cheaper to solve a problem at the prototyping stage than it is to solve it at the production stage. After you've spent thousands of dollars on a production tool and you get to the molding machine where it's going to be running 1 million parts for you, and you run that first part and you realize that the hole's in the wrong location, or the wrong diameter, or there's some other problem with it, then you've lost a lot of time and you will have to invest a lot more money to repair it at that point in the product life cycle.
So we did some sketches and models, and we did some 3D modeling, our designers did, and we came up with a form factor and concept that we thought we liked. And what we needed to do was to be able to produce some proof of concepts, as well as some prototypes that we could test and show our customer.
What they wanted us to do was they wanted us to produce 12 working prototypes out of plastic, and it would be a working model that they could put out in the community at different businesses and get some feedback or marketing for their product.
And we're real pleased with the result. So are our customers. This product first came on the market in this particular form in June of 2005, and since that time we've basically become the market leader in intercom systems.
Essentially, we have funding to help manufacturers with product development type issues, particularly rural manufacturers in the state of Kentucky who may have a product that they're developing, or may already have a product that they're long-term providing and successful with, but maybe it's ready to take to the next level with some intelligence in it, or just some redesign to help make it more cost-effective, or things along those lines. And so we can work with these rural manufacturers with the expertise that we have at the university and bring that to help supplement what they have at their facility to be able to develop these new products.
My name's Mark Rubel. I have a company in Frankfort, Kentucky called Metalworks Incorporated. I've been in business 18 years, and we do all sorts of metal fabrication, welding, fabricating, forming, cutting. And one of the parts that we are currently doing was basically a piece of trim, and we were forming and fabricating that, plus having it painted, and it was really labor intense. And I was trying to figure out a way to get away from that. So I thought about the idea of designing this part in a plastic, and then I happened to remember that the University of Kentucky had a program for business people, and if you had an idea of something that you needed help in engineering, the College of Engineering had people there for that purpose to help you develop these products.
We're just sort of an additional tool in the toolbox of the manufacturers that we're here to support. We also work with entrepreneurs and inventors to help them on, from a product idea standpoint, to be able to help develop the product and refine that to be something that would be cost effective and manufacturable, and hooking them up with manufacturers and getting that product out there.
Once we had the prototype developed for me, and we looked it over and actually fitted it up to the rest of the parts that it went to, I knew once I saw the prototype that we were on the right track, that it was going to work. Just from the materials that I use and the labor involved, I knew that it's going to be a phenomenal savings.
So we really like to think of our relationship with industry as symbiotic. That is, certainly the center would not be here if it weren't for industry and trying to solve problems that crop up. But we also hope that we have done, and I think the evidence is rather clear, that we have helped industry to stay in Kentucky, to stay domestic and not go abroad by working with them and solving problems. So certainly the basic mission of the center will continue for many years to come. You can look into the literature and you will see that these problems have been noted or mentioned 40 or 50 years ago, and we're still working on them today. But what excites me about the Center for Manufacturing is I think we have new directions, we have new opportunities on the horizon.
The center has another mission, of course, and that is research. And a lot of that research is done not only for industry, but in conjunction with industry. We have research, for instance, in metal jointing, which includes welding, which includes brazing, and some very, very exciting work that's going on there is at the best of any place in the world. We have outstanding work going on in understanding of lean manufacturing as part of our research effort. We do a lot of work in terms of machining, where we have very specialized facilities, and we work closely with industry in introducing new concepts in machining, especially machining that is more environmentally benign in that it doesn't use machining fluids and therefore is not as detrimental to the environment.
Research is probably one of the most important aspects of the center role. The reason why, because when you have strong research programs, that will enrich your educational resources, as well as that will be a very good incentive for industries to come to the University of Kentucky, to the Center for Manufacturing, seeking technical advice or seeking solutions to their problems. So it is very important that we have a strong research element in the center.
The future of metal cutting is very good in the sense, as you may know, metal machining is the largest manufacturing process in the world. It accounts for roughly about 5% of the GNP, and it translates into roughly about $240 billion in the United States alone. With a wide range of materials and unlimited number of cutting tools and measuring tools and all the equipment coming in to exist, the need for modeling and understanding and implementing these process parameters becomes very important. In particular, small to medium to large companies, all of them need optimized machining conditions. Some companies need selection of cutting tools. They need to find the best possible cutting tool for a given operation. Some other companies might need the best possible cutting conditions for available cutting tools. So we try to handle on an individual basis. And when it comes to manufacturing processes, we want to make the processes energy efficient, environmentally benign or environmentally friendly. We want to make processes that are truly lean in the sense economically feasible and efficient, and manufacturing environment has to be toxic free and hazard free and safe, and providing the best possible health conditions for operators. So all this put together, it works out to be sustainable manufacturing.
A key thrust in the center's research effort is sustainable manufacturing, which encompasses not only the practices that we use for machining and for metal jointing, but just the entire process, the entire concept of a manufacturing operation, from the onset when the materials are brought together to create the product and to the end stage of the product where it has to be disposed of and recycled properly. That is an emerging element of expertise within the center, and it gives us an expertise that is fairly unique in the United States still at this stage.
So every single stage of research we do here, like in terms of optimization, constitutive modeling, experimentation, every single task we do, we take it in the direction of sustainability.
Really, when we think about the problems that are facing the world these days, the only way to move forward is really to think sustainability. And we have basically to start addressing these crises that we're facing in terms of global warming and growth in population and ecological depth. All of these issues, we engineers must lead in order to solve these problems.
So two major processes that we analyze here are so-called brazing and soldering, both bonding techniques that serve the purpose of joining the metals, in our case, without melting the substrates. The kind of problems that we are dealing with are related to much smaller dimensions of the mating surfaces, problems that we call wettability, spreading of liquid metal over the surfaces, and removal of oxide layers over those formed over those surfaces. We are interested in understanding how this spreading, or how we say wetting, of liquid metal evolves. We can cover the range between room temperatures and thousands of degrees Fahrenheit. That means, let's say, up to 1500 degrees Celsius. And that allows us to monitor the process, to understand its kinetics, dependence on time, and to build the models that may be predictive and may tell us something about the ultimate outcome, which then will be translated into industrial application and needs for better designs. Another important aspect is an enhanced interest, a great interest in making those operations more green. That means in leading toward a goal for enhanced sustainability.
And so if you look at the research for the center, we're really working on sustainability issues then. That's the broad umbrella. Yet we're making names for ourselves, we're developing intellectual property in some of the fundamental areas of manufacturing, such as brazing, such as welding, such as machining, such as lean production systems.
The Center for Manufacturing really serves as almost a capstone experience for many of our students in the College of Engineering, both undergraduate and graduate. By capstone, I mean an overall, overarching experience that brings together many aspects of their educational experience. The Center for Manufacturing, through the way that it catalyzes research and educational endeavors from faculty from chemical engineering, materials engineering, electrical engineering, and mechanical engineering, is ideally suited to do that because of both the facilities it has and because of the staff that it has to support multidisciplinary activities. So in many regards, it brings the College of Engineering together in a way that it was never possible before its existence.
Think Forward. Think Research Channel.